All right, let's dive into one of the most stunning landscapes in all of North America, the Grand Canyon of the Yellowstone. I mean, just look at those colors. They're incredible, right? But the question is, how did this place even form? Well, I'll tell you right now, the answer is probably not what you're thinking. It's this wild recipe of volcanic fire, corrosive acid, and a whole lot of water. Let's get into it.
So, when you look at a canyon this huge, your brain probably jumps to one thing: glaciers. Like Yosemite, carved by these massive, slow-moving rivers of ice. It just feels right. But that's where the story takes a sharp turn. The real story is so much faster and, frankly, a lot more explosive. There's actually zero evidence that a glacier ever even touched the bottom of this canyon. Here's the deal. Glaciers carve these big, wide, U-shaped valleys. But the Grand Canyon of the Yellowstone? It's a classic V-shape. That's the telltale sign of a river. But this wasn't just any river cutting through any old rock. This canyon wasn't slowly ground down over millions of years. No, it was sliced open and fast, through rock that had been perfectly, well, pre-cooked by the heat and chemistry of a supervolcano.
So to really get how this happened, we've got to look at the three-part secret recipe that created this geological masterpiece. It's a story of creation, then destruction, and finally, this incredible rebirth.
And, like any great recipe, it all starts with getting the base ingredient right. For this canyon, that story doesn't begin with water, but with an almost unimaginable amount of fire.
The entire Yellowstone area is, for all intents and purposes, a giant volcanic field. Starting about 2 million years ago, a series of super eruptions just blasted this landscape. The most recent really big one, around 640,000 years ago, is what formed the Yellowstone caldera. It buried this whole region under hundreds of feet of volcanic ash and thick lava flows.
And those eruptions created a really specific kind of rock. We're not talking about the soft sandstone you see down in Arizona. This is rhyolite, a really tough, really resistant volcanic rock. And in its fresh state, a river would have an incredibly hard time cutting through it. So, how did the Yellowstone River do it? Well, that brings us to ingredient number 2, the real secret in this recipe.
This, right here, is the secret ingredient. It's the one thing that makes this canyon so unique. The very same volcanic heat that created the rock in the first place would ironically come back to basically rot it from the inside out.
The fancy scientific term for this is hydrothermal alteration. See, Yellowstone's volcanic plumbing is still super hot just below the surface. All that heat boils the groundwater, creating steam and hot acidic water that seeps up through all the little cracks in the rock, and it completely changes its chemistry.
Honestly, the easiest way to think about it is just rock rot. Imagine you leave a loaf of fresh bread in a really steamy kitchen for a few days. It gets all soft and crumbly, right? That's pretty much what happened to this super hard rhyolite. For thousands of years, intense heat and acidic steam just cook the rock, turning it into something much, much weaker and more brittle.
Now, not all the hot water in Yellowstone does the same thing. The water you see in the geyser basins, that's pretty neutral. It actually builds things up, depositing these hard minerals. But the water that made this canyon, it's different. It's acid sulfate water. It forms when volcanic gases mix with steam, and this acidic brew, it's just plain destructive. It aggressively breaks rock down, turning strong minerals into weak clays and pulling all the iron out.
And here's the proof. It's amazing. Scientists have used special imaging technology to literally map out the chemistry of the canyon walls. The image on the left, that shows where the rock has been chemically weakened. All those colorful patches are areas packed with weak clay minerals. Now look at the image on the right. This map shows where the iron is. The very same acidic process that weakened the rock also moved the iron around, which then basically rusted to create the canyon's famous yellow and red colors. So the weakness and the beauty, they come from the exact same process.
So now we have our foundation of hard rock that's been chemically cooked until it's weak and brittle. All that's missing is the carving tool.
And that's where the Yellowstone River comes in. And boy, is it a powerful tool. The lower falls alone plunges 308 feet. That's a whole lot of erosional force. So waterfalls usually form where a river hits a layer of hard rock on top of softer rock. It just chews away at the soft stuff much faster, creating that vertical drop. In this case, the hard cap rock is a layer of rhyolite that wasn't as hydrothermally cooked as the rest. The river is just tearing away all that weaker, altered rock downstream, leaving the tougher stuff as the lip of the falls.
But here's the kicker. The final carving was not a slow grind. About 14,000 years ago, at the end of the last ice age, a huge ice dam that was holding back Yellowstone Lake just
failed. This unleashed catastrophic floods with a power that's hard to even imagine. This supercharged river just slammed into that chemically weakened rhyolite and ripped through it with incredible speed, carving out the canyon we see today in just a few thousand years. I mean, that's a blink of an eye in geologic time.
This totally unique geological story didn't just create a beautiful canyon, though. It actually had a direct hand in shaping American history and sparking the entire conservation movement. So, let's just recap the recipe one more time. You start with a supervolcano's foundation. Then, you cook it from the inside with acid until it's weak and colorful. And for the final step, you blast it with catastrophic floodwaters. It's that unique combination that makes the Grand Canyon of the Yellowstone so incredibly special. When the first explorers, guys like Nathaniel Langford, saw this place, they were just floored. They knew it was totally different from anything they'd ever seen before. But to convince a pretty skeptical Congress all the way back east, they were going to need more than just stories.
They needed art. So in 1872, Congress paid an artist named Thomas Moran $10,000, which was an absolute fortune back then, for his massive oil painting of the canyon. And his work captured those insane colors and the pure scale of the place in a way that the early black and white photos just couldn't.
And that same year, inspired by that painting and the stories from the explorers, Congress created Yellowstone National Park. But get this, its first operating budget? $0. Not a single dollar. And that contrast tells you something really profound.
The big takeaway here is this. The unique geology, that recipe of fire, acid, and water, it created a landscape so visually stunning it was basically natural art. That natural art then inspired human art, which in turn inspired the political will to protect it. And that gave birth to the entire idea of a national park.
And you know what? That process isn't over. That volcanic furnace is still on, the hydrothermal systems are still cooking the rock, and the river is still carving deeper every single year. This masterpiece isn't some finished painting hanging in a museum. It's a living work of art, constantly being reshaped by the exact same forces that created it in the first place. Makes you wonder, doesn't it?
Enjoyed this video? Please like, share it with a friend, and press the bell icon to never miss an update.